Welcome to an exciting journey into the captivating world of optics. Today, we embark on an experiment to unlock the secrets of light and delve into the wonders of converging lens. Our mission is to determine the focal length of a converging lens. Let's get started. You are provided with a meter rule, a ray box containing an illuminated object pin, a converging lens and holder, a screen, and other necessary materials. Observation on measuring instruments. The least count or readability of the meter rule is 0.1 centimeters. That is the smallest length the meter rule can measure. And also, we are going to record the length in 1 decimal place. Place the lens in its holder such that it is facing a distant object seen through a well-lit laboratory window. Through the door, we can see this building at this side of the lens. And so we are going to move the screen to and fro until a sharp image of the distant object is formed on it. So we will rather move the lens holder until we see a sharp image of this object on the screen and then measure the distance between the screen and the center mark of the lens holder. There is a mark over here. So the distance between the screen and that mark is the focal length of this lens. So we have a sharp image of this building turned upside down, and we want to find the distance between the screen and the center mark of the lens holder. And is 15 centimeters. So this represents the focal length of this lens. Place the illuminated object pin at the end R of the meter rule. So we have the illuminated object here at the end R of the meter rule. Place the lens at a position P such that U is equal to RP is equal to 20.0 centimeters. We are going to place the lens at 20 centimeters from the box. So we place the center mark of the lens holder at 20 centimeters from the box, that is U. And we are going to move the screen to a position Q in order to receive a sharp image of the object. And move the screen to receive a sharp image. So we have a sharp image on the screen. This is at 20 centimeters and we obtained a sharp image at 80 centimeters. So U is 20 centimeters, and for V we obtain a sharp image at 80 centimeters, and the difference between 80 centimeters and 20 centimeters is 60 centimeters. But we will repeat the experiment again to obtain another sharp image and find V, and then determine the mean of the two values, that is V1 plus V2 divided by 2. That will be 60.0 plus 60.0 divided by 2, giving us 60.0 centimeters. So U is 20 centimeters, V1 is 60.0 centimeters, V2 is also 60.0 centimeters, so the mean is still 60.0 centimeters. And we are going to repeat the procedure for U is equal to 25 centimeters, 30 centimeters, and 35 centimeters. So we are going to move the lens to 25 centimeters from the box and then move the screen to receive a sharp image, and then determine the value of V. Repeat it for 30 centimeters, 35 centimeters, and then find another value for 35 centimeters, 30 centimeters, 25 centimeters, and then find the average of the two values. We are going to calculate 1 divided by U and 1 divided by V, and then tabulate the results. So 1 over U, the unit will be per centimeters, since 1 divided by centimeters is centimeters exponent -1. So we pick the first value, 1 divided by 20. For the second value, 1 divided by 25, 1 divided by 30, and 1 divided by 35. And then we find 1 over V, also in per centimeters. So we pick the first value of V, that is the mean. So 1 divided by 60 is 0.017. 1 divided by 37.5 is this. Then we find 1 divided by 30, 1 divided by 26.25. The unit should be written at the top here once, and it shouldn't be repeated with the values. And also, all the values under each column should have the same number of decimal places. So we have 1 decimal place here, 1, 1, but here we have 2 decimal places because it's a calculated value. It's the mean, the calculated value. You can leave it in the number of decimal places. That will give you accurate results. These are the plotted values. So leaving them in 1 decimal place will not give us enough information. As you can see, 1 decimal place, we have zeros here and zeros there. 2 decimal places too will not be enough. That is why we left them in 3 decimal places, because these are the values we are going to plot on the graph, and we need enough information to obtain accurate results. And we are going to plot a graph with 1 over V as the ordinate, that is the vertical axis, and 1 over U as the abscissa, that is the horizontal axis. So we need the values of 1 over V. For the first value, we move the point 1, 2, 3 and record it as 17 times 10 exponent -3 per centimeters. because 17 times 10 exponent negative 3 will give us 0.017. This will make it very easy to plot it on the graph. So for the next value, we move the point 1, 2, 3, and we have 27. The next one will be 33, the next one 38. All times 10 exponent negative 3, giving us these values back. So we also need the values of 1 over u. We move this point 1, 2, 3, and we record it as 50 times 10 exponent negative 3 per centimeter. For the next value, we have 40, the next one 33, and the next one is 29. So we are going to plot these values on the graph. So we draw the vertical and horizontal axis. And we are plotting 1 over v on the vertical axis. It should come with the units and the conversion. And we are plotting 1 over u on the horizontal axis. So we choose a scale. We will choose a scale of 2 centimeters to 10 times 10 exponent negative 3 per centimeter on 1 over v axis. So we start from 0, 10, 20, 30, 40, 50, 60, 70, and so on. And on this axis to the same scale, so we start from 0, move to 10, 20, 30, 40, 50, and so on. 10 divided by 10 is 1. So each small box on the vertical and horizontal axis is equal to 1. So for the first point, we have 50 on the horizontal axis and then 17 on the vertical axis. So this is 50 and this is 10. We count 7 more boxes and they will meet here. For the next point, we have 40 on the horizontal axis and 27 on the vertical axis. So we move to 20 and count 7 more boxes meeting here. For the next one, we have 33 on the horizontal axis. This is 30. We count 3 boxes to the right. And on the vertical axis to 30, we count 3 boxes. And we have the point here. For the next point, we have 29 on the horizontal axis. So this is 20. We count 9 more boxes and 38. So 30 plus 8 more boxes will meet here. So we draw the line of best fit. And we are going to determine the vertical and horizontal intercepts as M1 and M2 respectively. So the vertical intercept is M1 and the horizontal intercept is M2. Okay, so here we have 60 plus 7 boxes. So for the vertical intercept M1, we have 67. Remember, we converted it to standard form, so times 10 exponent negative 3, and the unit is per centimeters. And 67 times 10 exponent negative 3 is 0.067. For the horizontal intercept, we have 60 plus another 7 boxes. So M2 is also 67 times 10 exponent negative 3 per centimeters. And 67 times 10 exponent negative 3 is 0.067. Evaluate 2 divided by M1 plus M2. We know the values of M1 and M2, so we replace them and factorize the units per centimeters out. So we have 0.067 plus 0.067, which will give us 0.134. and 2 divided by 0.134 is 14.9. The unit per centimeters is at the denominator, so when we find the reciprocal, we have centimeters. The answer should be approximately equal to the focal length of the converging lens used for the experiment.